Composition of functions. Function composition is applying one function to the results of another. The result of f is sent through g. It is written like this, which means g of f of x. In other words, g composed with f of x equals g of f of x. Example: f of x equals 2x plus 3, and g of x equals x squared. X is just a placeholder. To avoid confusion, let's just call it input. F of input equals 2 times input plus 3. G of input equals input squared. Let's start. First we apply f, then apply g to that result. And we get 2x plus 3 all squared. What if we reverse the order of f and g? First we apply g, then apply f to that result. And we get 2x squared plus 3. We get a different result. When we reverse the order, the result is rarely the same. So be careful which function comes first. The symbol for composition is a small circle. It is not a filled-in dot, as that means multiply. Composed with itself, we can even compose a function with itself. Example: f of x equals 2x plus 3. First, we apply f, then apply f to that result. Step by step, f of x equals f of 2x plus 3 equals 2 times 2x plus 3 equals 4x plus 9. Domains. It has been easy so far, but now we must consider the domains of the functions. The domain is the set of all the values that go into a function. The function must work for all values we give it, so it is up to us to make sure we get the domain correct. Example: the domain for the square root of x. We can't have the square root of a negative number unless we use imaginary numbers, but we aren't. So we must exclude negative numbers. The domain of square root x is all non-negative real numbers. On the number line, it looks like this. Using set builder notation, it is written like this. Or using interval notation, it is written like this. It is important to get the domain right, or we will get bad results. We must get both domains right, the composed function and the first function used. When doing, for example, g of f of x, make sure we get the domain for f of x right. Then also make sure that g of x gets the correct domain from f of x. Example: f of x equals square root x, and g of x equals x squared. The domain of f of x equals square root x is all non-negative real numbers. The domain of g of x equals x squared is all the real numbers. The composed function is g of f of x equals the square root of x squared equals x. Now, x normally has the domain of all real numbers, but because it is a composed function, we must also consider f of x. So the domain is all non-negative real numbers. Why both domains? Well, imagine the functions are machines. The first one melts a hole with a flame, only for metal. The second one drills the hole a little bigger, works on wood or metal. What we see at the end is a drilled hole, and we may think, that should work for wood or metal. But if we put wood into it, then the first function f will make a fire and burn everything down. So what happens inside the machine is important. Decomposing functions. We can go the other way and break up a function into a composition of other functions. Example: x plus 1 over x, all squared. That function can be made from these two functions. F of x equals x plus 1 over x, and g of x equals x squared. And we get g of f of x equals g of x plus 1 over x equals x plus 1 over x, all squared. This can be useful if the original function is too complicated to work on. Summary. Function composition is applying one function to the results of another. G of f of x. First apply f, then apply g. We must also respect the domain of the first function. Some functions can be decomposed into two or more simpler functions. You can visit us at mathsfun.com.